Hello everyone, and welcome back to the podcast. I am your host Ichino, and I'm so incredibly excited to be here with you today. Today is Monday, June 29, 2026. I hope you all had a wonderful weekend and are ready to learn something new and exciting today. We are going to talk about a super cool new paper from the world of machine learning. And I am going to explain it just like we are exploring a fun new puzzle together in a classroom. The title of the paper we are looking at today is DanceOPD and Policy Generative Field Distillation. Our curl is arXiv.org/abs/260 6.27377b1. That is quite a long title. But do not worry at all. We're going to break it down piece by piece, so it makes perfect sense to everyone. Right? So let us start with the big problem this paper is trying to solve. Imagine you have a magical painting robot. We want this robot to do 3 different things. First, you want it to draw a brand new picture from scratch just by listening to your words. This is what we call text-to-image generation. Second, you want it to look at a picture and carefully change just one tiny thing, like changing the color of an apple without messing up the table it is sitting on. This is called local editing. Here, you want it to take a picture and change the entire mood or style, by turning a sunny photograph into a beautiful watercolor painting. This is called global editing. And here is the tricky part, and scientists try to teach one single robot to do all 3 of these things. The robot gets very confused. These skills naturally fight with each other in the robot brain. If it tries too hard to learn how to edit pictures, it forgets how to draw good pictures from scratch. If it tries to learn how to change a whole picture, it forgets how to preserve the small details when you only want a tiny change. They call this problem capability interference, which is just a fancy way of saying the skills are bumping into each other and making a mess. To fix this big mess, the brilliant researchers from ByteDance and several amazing universities created a new training method called DanceOPD. DanceOPD acts like a very smart teacher for our AI robot, instead of throwing all the lessons at the robot at the same time, which causes that confusion we talked about. It uses a clever trick called hard routing. This means when the robot is practicing, it only gets graded by one specific expert teacher at a time. If the robot is practicing text-to-image drawing, only the drawing expert checks the work. If it is practicing small edits, only the editing expert steps in. This keeps the lessons perfectly clear and separated. Furthermore, the paper talks about something called policy generative. Normally, scientists train these robots using old pictures that are already finished, but DanceOPD lets the robot start drawing its own picture, and then the expert teacher steps in right in the middle of the robot, making its own drawing to gently correct its course. This is like a teacher watching a student solve a math problem on the blackboard and helping them when they make a mistake, rather than just handing them a finished answer key. It helps the robot learn from its own actual mistakes. Now, how does this compare to other technologies out there? Where are the methods like joint training try to just mix all the data together in a big pot? But like we said, that makes the AI forget its original drawing skills. Another old trick is weight merging, where they try to mush 2 different robot brains together after they are already trained. But that usually results in a very mediocre robot that is not particularly good at anything. DanceOPD blows these older methods out of the water. It actually improves editing skills by over 8% compared to the methods, while keeping the original drawing skills completely safe and intact. It is truly a massive leap forward for machine learning. Let us talk about how this amazing technology can actually be used in our everyday lives. Learning rules. I have 3 super specific application examples for you based directly on the experiments in this paper. For my first example, let us think about online shopping and product design. In the paper, researchers show an example of a regular red apple sitting on a table. Using DanceOPD, they asked the AI to turn the red apple into a solid, clear crystal apple. Because this AI is so smart at balancing different skills, it perfectly changed the material of the apple to shiny see-through crystal. But it left the green leaf, the wooden table, and the lighting exactly the same. In the real world, furniture companies or jewelry makers could use this to show customers what a product would look like in a different material, like changing a wooden chair to metal, without having to set up a brand new expensive Photoshop. Moving on to the second example. Let us imagine you were a real estate agent trying to sell a house. Sometimes people take photos of their rooms, but the rooms are very messy and cluttered. The paper shows an amazing example where they take a photo of a messy rental room and tell the AI to tidy it up. Because DanceOPD understands global editing without destroying the local structure. It beautifully removes the clutter and cleans up the room. It keeps the exact same walls, the same windows, and the same room layout. This means real estate agents could instantly show buyers the true potential of a home. Clean up the pictures perfectly so buyers can imagine themselves living there happily. And, for my third and final example, let us talk about the fashion industry and personal portraits. The researchers demonstrated this technology on a beautiful photo of a model wearing an evening gown. The instruction was to change the dress from crimson silk to emerald green velvet with older technologies. Aren't your rules? Ask if a change might accidentally change the model's face and mess up the beautiful howl in the background. But with DanceOPD, the AI carefully swapped the red silk for the heavy green velvet, even making the fabric look thicker and softer, while keeping the model's pose in the background light and completely untouched. Fashion designers could use this to instantly visualize new clothing lines on different models. Or everyday people could use it to see how they would look in different outfits before buying clothes online. It is just so fascinating to see how carefully teaching an AI, step by step with the right expert teachers, can unlock such powerful tools for all of us by fixing the confusion inside the AI brain. Dan makes image generation much more reliable and fun to use. I hope you enjoyed learning about this amazing paper with me today. Thank you so much for listening to the podcast, and I will see you all next time for more amazing machine learning adventures.